Hello. Okay, we're going to start. This is 4.4, trigonometric functions of all angles, which is already titled on Canvas, so it doesn't matter. Okay, so what we're going to be talking about is, and you can use your unit circle to kind of help you understand this too and see this a little bit better, but basically it's kind of going to go back to when we were talking about, like today on your warm-up, when you did the you graphed a point and then you plotted that point and the different signs of each, like the positives and negatives of each trig function in each quadrant varies. So depending on the location of the terminal side of the angle, trigonometric functions can be positive or negative. So using your knowledge of the trigonometric function values, identify the functions that are positive in each quadrant. So essentially what we're thinking about is, and I'm actually going to get a little piece of paper here. So if we think about the graph, and so let's say we have a point here. So we know that this is the opposite. That would be positive because it's in quadrant 1. This is quadrant 1, 2, 3, and 4. So the opposite would be positive, the adjacent would be positive, and the hypotenuse we know is always positive. So in quadrant 1, everything is positive because anytime like opposite over hypotenuse, that would be positive over positive, positive. There's no way that we'd get a negative. So in quadrant 1, every single trig function is positive. So we just put all are positive. And you can see that when you look at the unit circle. If you look at the unit circle, all of the coordinates are positive as well. And so if you're thinking, okay, my x value is positive, my y value is positive for all of these in quadrant 1. So in this case, everything is positive. Okay, so then in quadrant 2, we're thinking is a triangle over here. I think this is the one that was like your warm-up. So this is now a negative adjacent and a positive opposite, and we know always a positive hypotenuse. So what's positive here? So anything that uses an A is not going to be positive. So the only thing that would be positive is anything that just uses the O and the H, which in this case is sine, and then its reciprocal, cosecant. So in quadrant 2, sine theta is positive, and so is cosecant theta. And again, that checks out if we look at our unit circle. So if I look at my unit circle, the y values are positive, and my y value is representative of sine in this case when we're looking at the unit circle. Okay, the next is quadrant 3. So quadrant 3, now with this, the adjacent is still negative, just like here, but now the opposite is also negative. And the hypotenuse is positive. So we did this before. The only way that we can actually make this positive is when we have a negative over a negative in this case, because opposite over adjacent or adjacent over opposite, a negative over a negative would get me a positive. Opposite over hypotenuse, that would be a negative over a positive. Adjacent over hypotenuse, a negative over a positive. So the only thing that would be positive in quadrant 3 is when we have opposite and adjacent on top of each other, so a negative and a negative, to make that positive. And so in quadrant 3, tangent theta and cotangent theta are positive because opposite and adjacent are what we use for tangent and cotangent. And then in quadrant 4, so in quadrant 4, we're here. Again, we have a positive adjacent, but now we have a negative opposite, and the hypotenuse is positive. Always positive for hypotenuse. So we're thinking, okay, what uses A and H to make that positive over a positive? And adjacent over hypotenuse is cosine. So cosine theta and secant theta would be positive. Now we have an acronym to help us remember which are positive, and that acronym, so again, looking over here, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And so what helps us, let me get a pen. Okay, the struggle. So all are positive in quadrant 1, so A. In quadrant 2, sine is positive, and then we know that the reciprocal will also be positive, but we just focus on sine for this acronym. And then tangent is positive in quadrant 3, and then cosine is positive in quadrant 4. So the acronym we use is all. So for the A, students for sine, take for tangent, classes for the cosine. And then we just need to know that, like, if sine is positive, its reciprocal cosecant is also going to be positive. If tangent is positive, its reciprocal cotangent is going to be positive. So this is telling us which values are going to be positive in which quadrant. Okay, so let's apply that to our first example. It says if cosine theta is greater than 0, so essentially what that's telling me is cosine theta is positive, and then cotangent theta is less than 0, which is telling me cotangent is negative. Usually I also just put tangent because these are written they're regular, so I just think what's the reciprocal? Which quadrant could the terminal side of theta lie in? So I kind of think it's like a process of elimination here. So I kind of write out my acronyms and I think, okay, so first, it's not all. It's not in quadrant 1 because tangent is negative. So then I look to see, okay, does it tell me one of them is positive? And it does, and that's cosine, and so this has to be in quadrant 4. So that means my angle measure of whatever we're talking about is in quadrant 4. Okay, so I want you to read through 2, try 2 on your own, and then come back and check your work. So you're just going to try it, pause me, come back, check to see how you did. Okay, so you should be coming back to check. So we're thinking, okay, if secant is less than 0, so that's telling me cosine and secant is negative. And then tangent is also less than 0. Tangent theta is also negative. Which quadrant? So again, this is kind of like a process of elimination. So we know, okay, it's definitely not quadrant 1 because we have 2 that are negative, and in quadrant 1, everything's positive. It's not quadrant 4 because in this case, cosine is positive in quadrant 4, and here we have it negative. It's not quadrant 3 because tangent is negative, and we know in quadrant 3, tangent is positive. So it has to be quadrant 2. So process of elimination there gives us quadrant 2. Okay, so now essentially what we're going to be doing is applying what we've already done with this idea of knowing what quadrant it's in. So our first example says if cotangent theta is equal to -4 and secant theta is greater than 0, find all the other trig functions. So the first thing we need to do is just figure out what quadrant is theta in, and then I'm going to use that to help me to draw my triangle. So that's really the first thing. So I'm just going to put that as like step 1. Identify which quadrant theta is in. And we do that basically kind of how we did up in example 1 and 2. So it's telling us cotangent theta is -4, which tells me, okay, tangent theta is negative. And then it's also telling us secant theta, which we know is the reciprocal of cosine, is greater than 0. So cosine theta is positive. So again, I think, okay, it's definitely not quadrant 1. And then cosine is positive in quadrant 4. So this has to be quadrant 4. Okay, so from there, I kind of start to draw my triangle. So I know I have a triangle in quadrant 4. We're always going from the origin, and then x-axis, my theta is always at the origin. And then just like we had before, I use this information to start to label the triangle. So it tells us, okay, cotangent theta is equal to -4. Well, we know cotangent, we know tangent is opposite over adjacent, because TOA. And so cotangent is the reciprocal. So it's adjacent over opposite. So that tells me, okay, first thing I need to know is, well, this is a fraction. So then I think, okay, how do I write that as a fraction? Well, any number that's a whole number, it's still a fraction, it's just over 1. So that tells me, okay, the adjacent is 4, the opposite is 1. So looking at this, I look and I go, okay, 4 and 1. But what about that sign? So I look at my graph and I think, okay, well, 4 is positive, but 1 is negative, which actually would make sense. If I did 4 over -1, that would get me the -4. So in this case, you have to, that's why I like to graph it, because it helps me to kind of visualize what's going to be like the signs, like the positive and negatives of each number, what each thing is going to be. So in this case, the 4 is actually positive and the 1 is actually negative. And I'll just make a quick note of that. So we know the 1 is negative after looking at the graph. And it is a negative y value. Okay, so then from there, I have 2 legs of my triangle, and now I just need to find the hypotenuse. So just like before, we're going to use the Pythagorean theorem. So leg squared plus leg squared equals the hypotenuse squared. So 16 plus 1. So x squared equals 17. So that tells me my hypotenuse is rad 17. Remember, the hypotenuse is always positive, so we don't have to ever worry about the sign there. And then we can just apply it like we've been doing before. So I'm just going to label my triangle. -1 is my opposite, 4 is my adjacent, and rad 17 is my hypotenuse. So sine, we know, is opposite over hypotenuse, so 1 over rad 17. We've got to rationalize the denominator, and that's -1 over 17. So it's negative rad 17 over 17. So I just rationalize the denominator there. Cosine would be 4 over rad 17 because it's adjacent over hypotenuse. And then rationalizing the denominator, that would be 4 rad 17 over 17. Tangent is opposite over adjacent, so -1/4. Cosecant is the reciprocal of sine, so that's going to be hypotenuse over opposite, so rad 17 over -1, which is just negative rad 17. And then secant is the reciprocal of cosine, so that's going to be hypotenuse over adjacent, so rad 17 over 4. Rad 17 over 4. Now, before I finish, I double check, like, okay, so it told me cotangent is negative, so is tangent also negative? Yeah, that checks out. It tells me, okay, secant is greater than 0, so cosine and secant are both positive. My cosine is positive, my secant is positive, we're good. So I'm going to pause this video here because in the next video, I pick up on 4. But other than that, that is it. Enjoy the next video.